Okay, apologies for the lateness of this video, but it's time that we got around to talking about granular synthesis again. In my first video, I introduced the kind of basic concept of granular synthesis. Okay, it's this idea of working with tiny grains of sound, tiny slices of sound, and we weave them together in order to kind of create these new masses of sound, right? Textures of sound is maybe a good way of thinking about it, right? It's very different to a kind of simple waveform style or a basic waveform style of synthesis, right? Things like using waveforms like sine waves, triangle waves, square waves, and kind of adding them together, or subtractive synthesis, FM synthesis, things like that. This is a very different way of working. It's fundamentally, we're working with a kind of different set of tools here, right? We are working with tiny grains of sound, not sand, and we're going to bring them together, create these big dense clouds of fragments, right? Now, in the first video, we built a grain generator. We built it in Max, and it allowed us to create a single grain of sound. Okay, the way that we did this was we took a waveform sample, and we took a tiny fragment of it, and then we applied a nice smooth envelope to it in order to kind of get a fade in and a fade out on these tiny section of sound. Okay, now our grain generator created one grain. Okay, that's what it did, and then what we did was we kind of strung it together and triggered it again and again and again in order to get multiple grains. But that doesn't really allow us to get to what is interesting about granular synthesis, right? It's this idea of working with these masses of sounds, these clouds of sound. And what we built last time basically was just, one grain plays, and then when that grain finishes, another one starts, and then when that grain finishes, another one starts. So it was just like a single train of grains, if you like. Okay. It wasn't really a granular synthesis. It was kind of sounded a bit more like a skittering sample kind of playback, right? So what we're going to do today is we're going to make a proper granular synthesizer. What we want to be able to do by the end of this video is to play multiple grains at the same time. Okay, we want grains to overlap so that we can get more of them. We can start to play with these, clouds of sounds, right? Each individual grain might have different characteristics, different parameters. We looked a little bit at that last time, right? So every single grain, and we might be playing, hundreds at the same time, might be playing from a different point in a sample. They might be playing in different stereo space or have a different pitch or something like that, okay? That's where granular synthesis starts to get interesting, when we start to build up multiple instances of grains with different characteristics. And that's what we're going to do today. But in order to do that, we need to find a way of making our grain generator from last time. We need to make that polyphonic, right? Polyphony meaning many sounds at the same time, okay? That's how you're able on a normal synthesizer to play a chord rather than just one note at a time, okay? To do that, we're going to use Max's poly object. Now, before we carry on, if you haven't got the grain generator that we built last time, you might want to head back to that first video, patch along with that, build yourself a grain generator, and then come back here, and we're going to look at polyphony. Okay, so here is my patch from last time, my grain generator. Now, the eagle-eyed among you might realize this looks a little bit different to the version that I made last time, and you might ask, reasonably, hey Oliver, did you forget to save the patch that you made a year and a half ago and just had to scramble to kind of assemble it again from the YouTube video? And the answer to that would be yes. Don't make my mistake. Make sure you save all of your patching and try and remember where you save it, which is also helpful, as it turns out. Anyway, maybe it's useful because it's given me a chance to kind of catch up on how we did things last time, and I've done some things a little bit differently. I'll just explain them very quickly. Here's our buffer that stores our sample. This is the the music that we're working with here, the content of our grain. And then down here I've got my my amplitude envelope. Now in the last video I know that I used a kind of nice Gaussian expression. I just took a shortcut this time. I used this little function here, which is just fill the whole buffer with ones and then shape it accordingly. So I've just applied a Hamming shape here. It's the closest we have to a straight Gaussian curve, so I just use that. You can also do like apply triangle and get like a straightforward triangle shape if you want. But if you went through the kind of Gaussian expression that we used last time, that's nicer, and so good work. Other than that, it's pretty much the same. I've got our random choice. Our rchoose is selecting the kind of grain start point, so we can kind of scan through that and get different points in our sample. We can change the grain duration, so the length of the grain changes, and accordingly we can also play around with the pitch of the grain. Okay. I've also got this little randomizer, so every time we trigger a new grain, so we do that up in the top corner, every time we trigger a new grain, I generate a new random position left to right in the stereo image. Okay, then the actual kind of main body of the patcher is happening down here. We have two line objects which basically just read through a kind of ramp of numbers, and what we're doing is we're just applying them together to say, in essence, start at this point in our sample, play until this point in our sample over this amount of time. Okay, so you know, we change the amount of time to get the duration, and the pitch. The two are related, and the amount that we need to move through. So like, how long is our grain going to be? But that's it. So this is our grain generator that we made. Now we're going to think about making it polyphonic using the poly object. Now I want to say this at this point in the video in case I forget to say it later, because the chances are anything that I kind of make a mistake on, I'll probably just edit out so that it makes me look more professional. The poly object is really elegant in what it's doing. Okay, it's effectively saving us the hassle of copying and pasting this whole section hundreds of times, right? But it has some, let's call them interesting characteristics. A lot of my students, actually that's not fair, I do it as well. Sometimes poly just behaves weirdly. I don't know why. Things should work and they just don't seem to. Okay, I know it happens and I kind of just shrug it off now, but I think a lot of my students kind of struggle with that. They think it's them making a mistake, and it's not. Not most of the time anyway. Sometimes poly just behaves weirdly. Okay, you think something should be working correctly and it's just not happening for you and you can't figure out why. That's absolutely fine, it happens. I found the easiest solution to that is the kind of classic IT problem: turn it off and on again. Save your patch and just reopen it again, and very often it seems to fix it. I don't know why. But as a result of that, I think a lot of people struggle with poly. It's really very simple, okay? And we're going to get into it now. But yeah, if you have some trouble, don't worry about it. It's probably not just you. Okay, let's get to work. So the poly object is really elegant. What it's going to do is effectively create a patch within our patch. And that subpatch, that poly patch, is kind of going to dynamically copy and paste itself as many times as needed. Okay, so if you imagine we're playing on a keyboard, we press one key and we want one note. Okay, we only need one instance of that note making thing. But as soon as we press another key, well, you know, we need another oscillator, we need another pitch. It needs to be processed and amplified, and then effectively we've split out. Okay, so now all of a sudden we need two channels, and we play a 4-note chord. Well, we need 4 copies of it, and you know, you start leaning on the keyboard and you need a lot of notes, and that's not really sustainable to just be copying and pasting another oscillator, another sample, another waveform, another envelope, all of this every time. What we're going to do is we're going to use the poly object to make our grain generator a kind of class of grain generator that represents all grains. okay? And they can have different pitches, they can have different, you know, sampling locations and start points and durations and stereo panning and all of this. They can all have different things, but they are all fundamentally a kind of copy of that one main grain generator, okay? The easiest way is to kind of just start to look at it. One thing I will say is that once we start working with PolyObject, it's going to give us two files, okay? We're going to end up dealing with two max patches. Now, I'm going to try very, very hard to kind of make it clear which one I'm working in, but I would suggest that what you do when you set this up is you have a new patch, which is going to be our main patch, and then your grain generator we're going to copy into the poly patch, which we're going to, I don't know, in the file name write poly somewhere just to make clear. So have your grain generator on a different window, as long as it's saved, not like me, and open up a new patch. And what we're going to do is we're going to create a new poly object. So it's poly tilde. And one thing I always recommend doing whenever you load a new patch, a new object that you haven't used before, particularly a complicated one like poly, is open the help file, okay? Don't take my word for it. I'm not going to explain the very detailed ins and outs of poly because it's not the focus of this video, and it's very complicated, or it can be very complicated should you choose to make it so, and there's lots of stuff that it can do that I'm not going to talk about. So pause the video, have a little look at this, have a read of this. It's going to give you an example. It has a nice instance where it plays an example, and if you turn it down, it shows you what's going on. Wonderful. We double click the synth and it shows you, okay, this is the sub patch, the poly patch that I was talking about. This is the example synthesizer. Have a look at this, okay? And then we'll move on. Now, so what I need to do is I need to take my poly patch, I need to give it a name, okay? So let's call this grain gen, okay? Because it's going to be our grain generator. Now, if I click on this, nothing opens because there isn't actually a patch there yet. We need to create that separately, and I think that throws some people off. What I'm going to do quickly is I'm just going to put in the other arguments that I'm going to need in a second. So I'm going to say the number of voices, let's start with 16. Okay, let's say it's going to be a 16 voice poly generator. I'm also going to put in this args #0. If you remember last time we used this as a kind of unique generator, it's kind of useful, and we'll not talk about it too much just yet, but we'll come back to it in a minute. Now, I've got all of the arguments that my poly object is going to need, but it's still not opening anything. So what I'm going to do is I need to save this. So I'm going to call this granular main. In fact, let's get rid of spaces just to make it easier. I'm going to call this granular main, and you see I've already got my grain generator patch up here. So I'll save that, and what I am going to do now is I'm actually going to change the file. You can see it here. I'm going to change the file of that max patch and just call it grain gen. Does that match what I called? Yeah, okay, there we go. So I've matched these file names now, and they're saved in the same folder. So why is it not working? First mistake. Okay. What's the other thing? Oh yeah, this one's sometimes good. I get rid of it, and then I type it again. Why does that work? Oh my god. Right, okay, well that worked. That's the other turning it off and on again, like just retyping the object. Anyway, okay, let me get rid of that. Let's try this again. So, I've got my grain gen object. Now that file name matches my original patch that we were listening to just a moment ago. Okay, so the file name matches. Then when I double click, hey, it opens up that other patch. Now this is interesting because it is a separate patch, right? It has a new file name. In the past we've used like sub patches like this, so I type P and then sub patch and I give it a name, and I can like encapsulate things, and that just pops up. That's within this. This is like a separate file, which is a bit confusing. But it's basically what allows us to make kind of duplicates of it. Okay, so we got there. Now, I'm in my main patch. My main patch has my poly object. My main patch is also where I'm going to listen to stuff. Okay, so let's get ready for that. So I'm going to have my line gain object because it gives me a nice little VU. I'm going to have my easy DAC, which is, you know, it lets me listen to stuff. So I'm going to get that ready because this is where I'm going to be doing the listening. I'm also going to control I'm going to trigger my grains from out here so we can kind of get that ready. So that's going to be going in there, and it's probably going to have to plug in somehow. So I know that's going to happen. Now, one of the interesting things about the poly object is that, you remember we talked about this idea of like, oh, you play a new note on the keyboard and it needs another copy of itself, another instance of itself. Now, that's kind of voice targeting. Okay, so it's this idea that like as soon as I play another note in the chord, it uses another finger, which uses another oscillator, which uses another and you kind of try and keep track of what's the index, the target of the voice, the number of voices. So we already know that we might be using up to 16 voices. One of the nice things about poly is that it works with MIDI, and it does a lot of the kind of voice targeting for us. Okay, it also does something called voice stealing, which you might have come across in like software instruments, where basically if I had like a limit of, let's say I had a 16 max voice grain generator and somehow I had 17 fingers, okay, when I press that 17th finger on, it's going to delete one of the first ones just so that I've always only ever got 16 voices. The point is, that's kind of complicated, and poly means that we don't really have to understand it because MIDI is going to kind of do a lot of that for us. So what I'll do is I will end up using MIDI note as a message, $1, $2, because I'm working backwards. I hope that makes sense. I'm going to pack up a note pitch and a velocity, so I'll use the make note here just to kind of give us let's say 60 as the pitch and a velocity of 100. So what this is going to do, right, is every time let's put that in so you can see it happening. Every time this kind of bang fires, it's going to create a MIDI note of 60, so a C, and it's going to fire it off into our grain generator. Okay, that's how we're going to trigger our grain generator. So basically, we're just going to say, okay, every 500 milliseconds, play a C, and that's going to say, oh, this is a note, this is a note, this is a note, this is a note. So we'll come back to that in a second. So I've got it ready. I'm going to go back into my grain generator now, up here, and a lot of stuff that we were using before when we were listening to this patch is kind of irrelevant now, right? I don't need, let's unlock it. I don't need this because I'm not listening. I'm going to be sending it out. So what I need now is an outlet, okay? In fact, I need two outlets because we're in stereo. Okay, so I can get rid of that. That simplifies that a little bit. And the inlet, similarly, I don't need to do the metro up here now because I'm going to do that outside the poly patch, right? So I can get rid of that. What am I going to do instead? Well, instead, now we know I'm going to be getting in a message that says MIDI note, and then the pitch of the MIDI note and the velocity of the MIDI note, okay? So what I will do is I'll need an inlet, so I'll say in 1. Oh, actually that's a point. These don't want to be that kind of outlet, these want to be another outlet, I think. Oh Max, why do you do this to us? So this needs to be out tilde 1, out tilde 2. down here, because these are going to be separate audio outputs. This is why it took me a year and a half to pluck up the courage to make this video. It's not because there's anything difficult about granular synthesis, it's just Poly is just a nightmare. Okay, anyway, we can do this. We can do this. So I've got my inlet, which is going to be a MIDI note. So I'm going to unpack that. So now that's going to give me the MIDI note, which is going to be the pitch, and it's going to give me the velocity. Now, MIDI has this habit of doing this thing where you get a note when you put the key down, and for some reason you get another note when you pick the key up. We don't want that happening, so we're just going to throw in this little strip note object, which basically just sort of says, just give me one. I only need one. So we'll do that, okay? That's gonna help us. Now, I get asked about this a lot. I'm going to use this trigger object, right? Rather than just having one bang, this is going to give me multiple bangs. The help file says it outputs any input received in order from right to left and formatted according to the object argument specified. Now, trigger is really useful because sometimes it lets me mix, or sometimes it lets me mix different kinds of things. So if I were putting in a floating number here, like this, it would give me lots of different outlets, but they trigger bang, bang, floating number, bang, bang. And it's kind of handy for in a few instances. I'm going to use it here, but I'm just going to trigger a bunch of bangs because we're going to use them for different things. And sometimes the order in which they happen matters. So what I'm going to do is, I'm going to do that. Now, we actually don't need this anymore. What we do need is each of these is going to get a random number. So I'm going to hook those up. Nope, not that one. This one. Okay. Okay, does that make sense? To me? I think so. I think so. Yeah. Okay, right. So, the next thing about our poly object is that if we are copying and pasting a new kind of instance of this every time we need another note, that could very quickly get messy. Okay, our computer might not enjoy just being told we need another one, another one, another one. At some point you need to let up. Okay, now because each of these instances of this poly object is going to represent one grain. Now, if we're using tens, hundreds, thousands of grains, that's a lot of poly instances to create. What we want to do is we want to use what's called a done action. We want to say, okay, once that grain has finished, you're fine. You don't need to do anything else. You can retire. And so each time we're actually limiting the number of grains that we ever need to create because they retire once they've finished, right? And we use another object inside this called this poly. This poly basically allows us to kind of turn on and off the DSP, the digital signal processing, when we need it, and turn it off when we don't. Okay, so what we can say is we are going to new message. We're going to say mute 1 0. That's going to go in here, and I'm going to add this load bang. We've seen this before, right? Load bang is kind of fires a bang whenever the patch first loads. So when we first trigger, we want it off, and we also want it off when our envelope finishes, so we can take the other out here. So this is, if I hover, you can see bang when line reaches destination. When the envelope finishes or closes, we can turn it off again. But when we trigger our bang, we need the opposite. So why do I keep making new objects? We want mute 0 to 1. So we want to switch it on. What we can do there is we trigger this here. Okay, so this is going to be the first thing we do because we're reading from right to left. Now, let me just write a little comment here, just so busy, turn DSP on. That's what this one's going to do. And now we're not busy, so we'll turn the DSP off. Now, got a little bit messy here, so let's just clean this all up. That's Control Shift and Y. Every single video, I forget to tell people. I get a million comments asking what that control is. Control Shift Y. Okay, so that's my new grain generator. So it's pretty much doing the same thing as before. Except, here's one. Except these are all 0. So if I were to play this now, it's not going to be doing anything because it's got some weird, it's got some problems here. I've spotted another problem as well. We don't want this here, okay? Because we don't want to be loading an individual sample for every single grain. We don't want to be loading an individual envelope for every single grain. That's a huge waste of resources. So what I'll do is I'll take these, I'll copy them, I'll go back to our main patch, and I'll put these up here in our main patch. Okay, that's going to take care of that for us. Now, what else could I do? What else could I do? Okay, well, we could put in some more inlets and outlets. That's a thing that we could do. Come back to this. So we've got one inlet that's going to be our trigger. What if we had another one that was... Let's bypass the random numbers for a minute. So let's say input 2 is going to be our grain start point. Input 3 is going to be our duration. We can change pitch as well. Yeah, let's do that. And input 4 is going to be our grain pitch. Okay. So now we can set those from the main patch, which is nice. Right then. Let's go back. Well, we can delete this now as well. Let's go back to our main patch. One thing you'll have noticed is that I've got, well, I should have 2 outlets and 4 inlets in this object, and I don't. Okay, it's that annoying problem that we had at the start where it wasn't updating. So what I'm going to do is I'm going to go back, I'm going to delete the name. Oh, there's got to be a better way. If anyone knows the proper way of doing it, there we go. There they are. So I've got my 2 outlets, which I can connect up here, and I've got my inlets, which we know were going to be my, I want to say grain start point, grain duration, and pitch maybe? Let's just write a comment so that we know. Start for this one. Duration for this one. And pitch for this one. Well, pitch ratio. Okay, so we can start, well, we can start at 0, that doesn't really matter. We can say our duration, let's have that as 100, and our pitch is at 1. Now, is this going to work? Of course it's not going to work. Why is it not working? What did I do? What did I do to deserve this? Well, we've got the right pitch, we've got the right duration and the start point. We could try the start point, changing that, see if that does anything. Doesn't do anything. Got the right sample. Let's go in, see if this is... Oh, now that's interesting. I'm not even pretending that this was like a great segue for me to talk about something that I'd forgotten. I genuinely forgot, and that is interesting. Now, anyone spot what's happened there? this should surely say #0 sample and #0 grain env, right? Because that's what we've got out here, but it's not. Reason for that is that because of this args #0, what it's basically saying is this is the first level of unique identifier, and any other #0s that happen below are also going to be unique, and that's not what we want. We want them to be the same. We want them to be kind of nested, right? And in order to do that, back in our grain generator, we want to change this. So if that was when it's locked, when it's unlocked, it goes back to #0. What I'm going to do is I'm going to say, no, don't give me a unique number here. Give me the unique address of the one above. So I'm going to say 1. So this is the next instance, right? The first instance from #0. Okay. We can hopefully see that play out in just a second. So I'm going to save it. I'm going to lock it. I'm going to close it. Ugh. I'm going to have to do that thing again, aren't I? Let's see if I can get away with just doing this. Still not working. Is it right now? Yeah, it's right. See, now it's gone to #0 again. But when I unlock it, #1. Okay. Let's figure out why this is happening. What have I done? Ah, okay. Could this be it? Have I triggered the wrong thing? Because I'm not doing random numbers anymore. Does that help? I think I actually know what the problem is, which is going to be annoying if this is right. I think I was just using the make note wrong. Let's find out. Oh. Okay. We've got something. Let's make this a bit faster. Interesting. I'm hearing something, but it's definitely not happening when it's supposed to. Now, it's confusing because I can't actually tell if I'm playing multiple notes at the same time because they're all playing at the same start, right? Which is a problem. So we need to find a way of getting that random start point in so that there is some variation, so that we can tell if these grains are actually playing at the same time or not, because I'm not sure if it's working just yet. So let's have a look. So we need to find a way of sending a value. So I still want to use these, but I also want to use that random number thing. So what I'm going to do is I am going to use the send argument. So let's say grain start. I also need to put in #1, no, #0, and then the next one will be #1. There we go. To give me that unique identifier, and I'll do the same for my duration, and I'll do the same for my pitch as well. Better make it match. Now, so I'm going to use the send objects. Now, there's also a shorthand you can use if you like. You can just use S. And on the other end of things, instead of using receive, we can also just use R. So I now have these set up out here. They don't need to be connected, so we don't need to use the inlets anymore. So I can go back here. I can get rid of these. Now we don't need inlets anymore, and instead I can do receive or just R, and they're going to be #1 grain start. That's going to help us choose our minimum grain start time, and then I should probably also do another copy that says how far. Okay, for the time being, let's just do plus 1000. See if that works. And I'll do the same for the duration, except probably not plus 1000. How long could it be? It could be 100 more. And then finally, the last one will be pitch. That will go down here. Oops, I already had that in. Right. So, assuming that that is correct, go back to my main patch again. I had to edit out the moment where I fixed or realized what the problem was, because obviously I had the volume turned up, so I deafened myself when that happened. Don't do that. When you're debugging, turn your volume down, because otherwise you might get a nasty surprise if you accidentally fix the thing. Now, I'll show you what was the problem. Before, when I'd gone and changed it over to just be directly triggering the note, I was bypassing the random choice, so I just went back and made sure that I was triggering the randomize choice option. Now, what I want to do is I want a better range here, so I'm going to have receive, start, high and low for both of these. So I'll say low and high, and this will allow me to set them in the main patch, and it will give me a bit of better control. So this will set here and set here. Bring these down, make it a bit neater, a bit more sensible in terms of layout. Now, so everything looks sensible there. I'm going to save this. I'm going to go back. I'm going to have to reinitialize this again, I think. Okay, so I also now need, okay, let me move these over just to give myself some space. I'm trying to keep this space down here in the bottom right corner, because I imagine that's where there's going to be a little video of me. So feel free to use, no, that's not right. So these are going to be the low. And high. Do that, and that'll give me a minimum, and I can kind of set the range and do nice things. We could use, I like to use the R slider object for doing these kinds of things. Kind of gives me a bit nicer control. Oh god, this has all got a bit out of hand. I'm really sorry, you're gonna have to just bear with me while I just line up my patch neatly, because that's the thing that I seem to have to do. Not a bad habit. I strongly encourage all of you to keep your patches looking neat, or neater than mine anyway. There we go, and then I should set the ranges. So I'm just gonna, you might not be able to see this, my camera might be in the way. I'm just gonna set the range of these R sliders. So I'm just gonna set this one, let's just try 2000 here, so it lets me, actually no, let's say 5000, because that's 5 seconds, it's in milliseconds, and the duration, that could be, Let's do 2000. Let's do 1000 because I want to show you something. So now, there we go. Okay. Get rid of that. That's causing a problem. Pitch. Now, fingers crossed, if I turn up the volume and turn the audio on, we will have a grain generator. We do! It sounds horrific. But now it's obvious that these grains are overlapping because we hear these different kind of start points and there's kind of a bit more coverage. I could also, it's much wider, and make the grains longer. Starts to get a bit interesting. I'm going to turn that off. Let's have something a little different. 1 second. Okay, I've replaced the not telling you what the sample is for copyright reasons sample with just a nice sample of a Fender Rhodes. Okay, it's just some nice notes. And now when we get something a little bit less frenetic and we start to kind of overlap those, we get something kind of interesting. Let's bring this down an octave. And if I take this way up to make this a much wider, in fact actually, let's see, how long is this? Total time of my sample is like 84,000 milliseconds. So I can just change that to kind of give me a bit better representation. And while I'm at it, let's change the range of this to like 2000. So we could have grains, the duration of a grain could be up to 2 seconds. Now that's not really where we started. Remember, we came from this idea of working with tiny fragments of sound, right? 20 to 50 milliseconds. And now I'm saying, hey, like 2 second long grains, they're probably not really grains anymore. But it's a granular kind of philosophy or inspired interpretation here. But well, let's see what we get now. So if I have a much wider range for randomizing the start of my notes, let's just take this down, make it a bit slower. Let's just say every 500 minutes. Yeah, these are very short grains. You start to bring it up. That doesn't quite sound long enough. I think there might be... okay. So this was a holdover from the original version that we had when we were doing all of the controlling inside. Now, actually, this R slider is causing a problem because it's limiting the numbers, you see? It was meaning that I wasn't getting a really long range. So let's change that. Let's bring this back. Here we go. So now I've got much wider, so like this is basically like the whole sample here. And my grains are varying from 197 milliseconds to 1578. That's 1.5 seconds. Okay, so let's bring it back down. Short grains, but from all over the sample. Now let's bring this right back down as well, because at the moment we're triggering these pretty sparsely. So let's say, there we go. If we bring this up, nice. Play with the pitch. If you've seen the sequencing video that I made and we looked at this coin toss method, so, you know, basically randomly splitting, you know, a 1 or a 0 or 0 to 100 or something like that, you could use the grain pitch, you know, to kind of do this method that like every pitch is either going to be a 1 or a 2 for an octave higher, or a 1 or a 0.5 for an octave lower. And what you'd end up with is this really nice kind of range of pitches, or kind of spread of pitches where they kind of move across the octave. Now, one of the problems with using this method of kind of defining the pitch for each grain is that even though we're using kind of, you know, a MIDI note to trigger, I can't just plug in a MIDI keyboard and play a note and get different pitches, because, you know, this note isn't the thing that's creating the pitch. If I just show you here, if I put my note in, and I actually, in fact, if I disconnect this for a second, so if I turn that back on, you'll see there are no grains being triggered at the moment. Now if I connect in my MIDI keyboard and just play, like, that's not setting the pitch, that's just triggering the notes, triggering the grains, okay? It has no effect on the pitch. I'm kind of moving all over the keyboard here and it's not changing the pitch, because this is the thing that's changing the pitch, right? So if I wanted to change the pitch, let's connect this back up, turn that down. If I wanted to connect, I would use my note in object, my MIDI, and I would say, okay, let's go MIDI note to, no, it's not to frequency. We're not dealing with frequency, we're dealing with transposition ratio. I want to say, there we go. Yeah. So that means, oh, that's slightly more complicated. Okay, so that means let's get a key slider, because then you can see it. That's a bit easier. There we go. Right. So I'm playing on my keyboard there. What we would need to do is figure out the transposition from C. So is that right? Let's find out. If I got that right. Hey, there we go. Okay, so C, middle C, is 1, which is what we've got. So I could hook that up. And that would then scale this accordingly. So then I go down an octave. I can kind of move around. Now, one of the strange things about this, let me turn that off, is that even though we've set up this poly object to allow us to kind of polyphonically work with our notes, because we're not controlling the pitch through that function, it's not really letting us play kind of chords on a MIDI keyboard. To do that, it's a little bit complicated. You end up having to create basically like a call table which tracks what notes you're holding down and what notes you've let go. I'll try and do a video on that another time, because it's a little bit complicated. In the meantime, you're probably better off sticking with playing around with kind of getting these textures by changing your pitch through this method. It's a little bit more intuitive, I think, than kind of starting to work with like lookup tables and stuff, which can be annoying. Now remember, we started, this is just a 16 voice version. You can also kind of start to increase this as well, and sort of start to work with other ways of triggering your notes. Oh yeah, I need to reset. So, you know, this is your voice limit here. You can start to increase that, go up and see how far your computer will let you go. But, you know, you can also start to play around with other kind of ways of like automating these so they move, maybe hook them up to an LFO, or start to control them through other things, because you control these through MIDI as well. Instead of randomizing these points, a kind of nice thing to do is something like, okay, let's just say, give you a space of like 10 milliseconds, kind of doing like a scanning function where you basically just like you're able to kind of move through the sample by keeping a very like relatively contained start point, so that, you know, the minimum and the maximum are only 10 milliseconds different, and then you can kind of use this to sort of scrub around. That would work particularly nicely if you were using like a percussive sample. Let's just quickly try that. What have we got here? Amen break. Let's do that. God, am I going to regret this? Yes, because it's very short, of course. And you end up with this sort of semi-frozen version. Start to widen it out. Get rid of that. Okay, I'm in danger of having too much fun. Okay, so there is your very basic. Oh, you could also start to randomize the metronome again, like we did before. I think I did this in the sequencing video as well. The kind of random self-randomizing metronome, where every new note you generate a new random number. You can start to play with that. Start to play around with thinking about the texture of your grains as well, like how they're triggered. At the moment they're just being triggered regularly like this, okay? But what if you started to have a bit of variation there? What if you started to sequence your grains, okay? You know, sequence on a kind of micro level, right? Really, really rapid 16-step sequencer, for instance. That could be really interesting. Again, getting distracted. The point is, this is the kind of most direct way of kind of triggering multiple grains at the same time, overlapping, allowing you to start playing around with these ideas of clouds of sounds and kind of granular samples. Now, I don't know if it's still around. I assume it probably is. This is very similar to and kind of based partly on one of the early Max examples of granular synthesis, where it uses the scrubbing function rather than randomizing things. You could also have a look at that, and there are other granulators online that you could look at. If anyone uses Ableton Live and Max for Live, Robert Henk's Granulator 2 object is beautiful. It's very, very kind of complex and really, really amazing to kind of look at and get some more ideas for using granulation. Now, as I said before in the first video, like, we owe a lot of this technique to this book. My desk is a mess, sorry. This is Curtis Rhodes' Microsound. If you're really interested in this technique and you want to see where it can go and take into really kind of far out conclusions, this is a good book to check out. It's really nice. So I would kind of recommend if you're into that. If you just want to make some real nice pads with kind of ambienty, washy sounds, you can do that now. Go away, play around with your grain duration time, the samples that you put in. You know, like this is not the most elegant kind of instrument that you've made, but all of the basics are there now. You have the tools to go and make yourself a really, really nice granular synthesizer now. I hope that's helped. I know it took a long time to get to this video. I'm very sorry. There are some other things that are kind of related to this or done differently that it makes me think would be interesting to talk about, particularly when we had that idea of the kind of, you know, scrubbing through the sample. It reminds me of Jean-Francois Charles' spectral freezing in Max, spectral kind of grabbing a moment of sound. Maybe we'll take a look at that in a future video. Hopefully it won't be another year and a half before I get to that. But thanks very much. I hope you have fun playing with this, and yeah, go and make some wild sounds. Thanks, everyone.